in this video we are going to discuss about Arduino. So by the end of this lecture, the students will be able to distinguish between computer organization components. They can able to differentiate between the microprocessor and microcontrollers in their size and architecture, able to understand the functionality of the system buses, namely address, data and control lines, and they can analyze how the Arduino platform handles embedded software and the physical computing task. So this is the content we are going to discuss. So we will first establish the introduction to the microprocessor and microcontrollers, and from there we can go to the AT-MEGA 328 processor. Finally we cover the Arduino programming interface here. So here you can see the foundational block diagram. Looking at this structure layout, we can find out that computer platform relies on the input block which provides data to the control unit. So here the control unit will act as a coordinator, and this will pass the data to and from the ALU, that is arithmetic logic unit, for computational execution, and this utilizes the memory for temporary or permanent storage. Then finally the output is displayed in the final results. So how does it works and how it maps these abstract blocks means the input maps to the keyboards or sensors, the output maps to the monitors or activators, memory maps to RAM or hard drives, and this ALU will rest inside the central CPU core. So finally we must remember that a functional system is always a combination of hardware and the software, where the software is explicitly tied into some system software like operating systems. And the application software are designed for the specific user operations. And now let us introduce the formal concepts of the microprocessor. As highlighted by the dashed boundary lines in the block diagram, a microprocessor contains strictly the ALU and the control unit. So it is the pure computational engine to turn this microprocessor into functional microcomputer. An engineer must externally connect the memory arrays, clock crystals, input or output peripherals around it. This slide actually highlights the fundamental hardware differences between the microprocessor based on the microcontroller. While we can still attach the additional external memory if the project requires it, or if the specific system is entirely self-sufficient in it. And here you can see the memory integration. So microprocessor requires external memory elements, integration chips, sizes and the cost. Applications, it can be used in the general purpose computers where the microcontrollers are optimized for dedicated specific task functions. And to pass the data between these blocks, we must rely on the bus in architecture. So a bus is actually defined as the highly synchronized pathway from the rapid transfer of digital information between different units. So when a processor performs a write operation to update the memory or command, an output will coordinate three things simultaneously. That is, it outputs the physical location through the address bus and places the actual binary data into the data bus, and then execute the pulse over write to control signal. So these are the address bus, data bus and the control bus are now ready to rebuild the computer organizations, where this pathway carries the signals from processor to the peripheral signals, which is unidirectional, and in the data bus it is a bidirectional, and in the control bus it carries the timing. Thank you.